All right. So before we get going in this bell work, at the very, very top, it has a little note for you guys in particular. Because there's been a problem in here this week. Literally every day, there has been some sort of breakfast trash left in my room, or a spill, or a wrapper left out and about. This room is clean when you guys walk in. It should be exactly as clean when you walk out. So if you spill something, or make a mess, or eat your breakfast, clean up after yourself. I'm not your mother. I'm pretty sure your mother doesn't clean after you like that anymore. Or I'll stop being nice about the whole breakfast and food thing. Okay. It's been literally every day. There's been trash or wrappers, granola bar wrappers, bins from breakfast things, popcorn or the Pop-Tart wrappers, juice spills on 2 or 3 different desks. And my second period is winding up cleaning up after you guys. So, fix it, or I won't let you eat in here anymore, and I'll be mean about it. Awesome sauce. Okay, moving on with what we need to do. Yeah, I know, I'm going to fall back into awesome sauce. That becomes my verbal crutch for a hot minute there whenever I say it once. All right, so let's do this bell work here. For his birthday, Juan is given a gift card to pay for his video game subscription. The funds remaining on his card after each week are shown in the table. X is the number of weeks, because X is always going to be our unit of time. And Y is the amount of funds available, so it's the money. So sometimes when we have something like this, it's helpful to label it once we get the letters. That this is my X and this is my Y. And I know you guys don't have the table, but I'm labeling it anyway. Except that X doesn't look like an X, it looks like a funky Y. X, there we go. Now it looks like a pirate X, but oh well, we get the vibe. All right, so first question is, what are the X and Y intercepts? And we're going to be specific. Well, what is the X intercept? And what is the Y intercept?
The X intercept is 5, 0.
It is indeed 5, 0. How can we tell it's going to be 5, 0?
Because in our graph,
Mm-hmm.
it shows that 0 is in the Y place
Yep.
and X is 5.
Yep. Because 0's in a Y place. Period. End of sentence. That's all it needs to have. 0 in the Y place. That makes it an X intercept. How about for my Y intercept? 0, 50. Because 0 is in the X place. So my Y intercept is at the point 0, 50. And so part B is asking what that means. We're putting that into context. So for our x-intercept, what does that mean? 5, 0 tells us what? Mm-hmm. Amount of weeks. Doesn't matter. We can do it either way. Amount of weeks. So the amount of weeks until funds left is what? Mm-hmm. Or how long till he runs out of money? He'll need to refill the card in 5 weeks. You could do amount of weeks. You could say 5 weeks until he has no money. It can be the amount of weeks until the funds is 0. You can use our titles exactly how it is. How about our y-intercept? What does that mean?
The amount of money on the card.
Mm-hmm. The amount of money on the card when he was given it. The original amount of money. I never remember how many M's in amount. Whatever. Y'all get the vibe. On the card. The original amount on the card. The initial balance. Where he started. At 0 weeks, available funds is 50. All of those are equally valid. So you can put it into words like how we talk, or you can do it with our labels exactly how it is, which sounds a little bit robotic, but totally valid. 0 weeks until available funds is 50. At 0 weeks, available funds is 50. At 5 weeks, available funds is 0. All right, then let's look at the bottom one. So all we're asked is, are these graphs linear or nonlinear? So look at A. Is this linear or nonlinear? Nonlinear. On the homework it says you can just put NL, so we'll just do that here. So A is nonlinear. I'm just going to write it over here because I don't like that. But I didn't write the homework, so, you know, it's a vibe. How about B?
Linear.
B is linear. It's a line. If you're feeling suspicious or paranoid or whatever, you can always grab a ruler and check it. We're not that mean, but it does line up with a line. Yeah, I know. You're not lying. I went back in. Hush. So if you're suspicious for some reason, feel free to grab a ruler. I have plenty, and you're welcome to check it. But we're not going to be that mean where I just curve it barely. So, all right. Questions on these? Okay, so I'm going to go to our vocab page. It's going to look like a lot, but they're all very, very related. Okay? So, boop. Here. Yes. Oh, yeah. Okay, cool.
The news just dropped. Then White Thunder. They did now, but like they just redropped. It was a redrop.
Yeah, the redrop.
Shoot. I mean, shoot, right?
The white one and the blue one dropped at the same time.
All right.
They jumped up the day after.
I love that we are passionate about our shoes, but let's lock it in. All right, because we're going to talk about extrema today. Extrema are a special thing that we look for, and we're going to look for it lots and lots of times over the course of the next year. We work with extrema pretty much all year. And all extrema means is extreme points, like highs and low points. So extrema are the high and low points on a graph. You can also think of them as places where it changes directions, where the graph turns. So what I mean by changing directions, I'm just going to do a little graph up here. If I'm going to draw a U graph, I'm going down, 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 up, 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 up. This place where I switched from going down to going up, that is an extrema point. So that's what I mean when I say changing directions. It's going from decreasing to increasing or from increasing to decreasing. So we've got 4 pieces down here, and these are all extrema. These are names for different kinds of high and low points on a graph. So our maximum, which is sometimes also called the absolute maximum, or just sometimes the absolute max, is the very highest it ever goes. It's like a mountain peak. So it is the very tippy top ever, anywhere, ever on that graph. Very, very similarly, our minimum, which we can also call our absolute minimum, absolute min, is the very lowest a graph ever goes. It's the absolute lowest it can go. So I'm going to draw us another kind of random squiggle that we're going to use to talk about these. So I'm going to just do it. It's going to look kind of like a heartbeat line that you see on TVs. So I'm just going to go like boop, 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 boop. There we go. I'm just going to do this. So our maximum, our absolute max is the very, very highest it ever goes. So for this little squiggle, it would be this piece way up here. That would be my absolute maximum. The tippy, tippy top. My absolute minimum would be this bottom thing, this deepest valley it can ever be. That's as low as it ever goes. Is that? Okay, so we have 2 other places here where it changes directions. I've got this one. I might get a different color here. Go red. Ooh, it's almost impossible to tell that from the pink, so hang on. Bright red. There we go. That's clear. All right, so there's that one. It's very similar to a maximum. Like it's a little bitty mountain hill. We're going with it, mountain hill. So it's a little bitty hill, or a little baby mountain. It's not the very, very highest that it goes, but it's still the same kind of flavor. That's what we're going to call a relative maximum. It is the very highest of its neighborhood. So a relative maximum, which when we're writing, we very rarely want to write out both of those words. You can write it as an R max. Is the highest point but only relative to its neighbors. So it's the highest point, but only relatively. Relative to its nearby points. It's a little baby hill. It's not our absolute max, but it's still something important. And then our last one is the relative minimum, which very similarly is going to be our R min. You can absolutely write out the word relative and minimum, but very rarely do we actually like writing that much, and there's way too many dang M's in minimum and maximum. And all that is, it's very similar to our relative maximum, is it takes the little baby valley. So it's not the deepest it can go, it's not the absolute lowest, but it is the lowest of anything nearby, of its neighborhood. It's the lowest point relative to the nearby points. You can think of our maximums like mountains. And our minimums are very much like valleys. So if that helps you, anything minimum is a valley. It's a dip. It's a divot. Mountain is, the maximums are anything that is a hill or a mountain or a peak or whatever word works best for your brain. And we're going to find these and we're going to label them. Not every graph is going to have all of these. In fact, almost no graphs have all of them. Most of them have at least one, but not every one of them does. So we're going to practice identifying them, we're going to look at them, and we're going to figure out what's going on. Okay? So, because of that, we need some graphs to look at. Shock of all shocks. I have graphs. We're so surprised. Oh my gosh. Okay. So we're going to identify our extrema, and then I'm actually going to have us do our domain and range as well, because we definitely struggled with that on, you guys can always turn the view into cool and not too hard. I have some people who decide they want to live in their fiancé life, just live in that constant wind tunnel. So we keep turning my fan at that desk. But if it bothers you, feel free to turn it. But we're also going to do our domain and range because on the homework 1-1, we struggled with that. Struggled. That was not super awesome. At least the ones that graded. The ones that are in Canvas, which should be in Skyward today. Yeah, they weren't great. I marked a whole lot more than I typically do just because I wanted us to see we got points for completing it, and some of us, those are the only points we got on it because we didn't really have many domains and ranges correct. We got points for completion, but we weren't super great at it. So we're going to find our extrema, and we're going to do domain and range for both of these. We've got an f of x and a g of x. Bless you. Bless you. So I'm going to give you guys some time to glue that in. Because we're only doing these 3, so we should be okay on time. Be nice. from this kind of U-shaped one. First things first, we're going to figure out, does it have a maximum, a mountain, or does it have a minimum, a valley? A valley, a minimum. Where does it have a minimum? Right here, right? Yeah, it's counting by twos. It's just being kind of annoying with that because, again, the book loves to make weird scales. I would absolutely take negative 4.5. I could 100% see the argument for that. No worries. So this has a minimum at the point 0, negative 5. And is that an absolute minimum, the lowest it ever goes, or is it a relative minimum, kind of a minimum?
Absolute.
It's an absolute minimum. That is the lowest it ever goes. So that is an absolute minimum. Does it have a maximum?
No.
No. If it has an arrow pointing in that direction, up for maximum, down for minimum, it will not have an absolute. It can have relatives, but it never is going to have an absolute if there's an arrow going that way. So that's our extrema on this one. It's the only one we've got. It's the only time it changes direction. It's going down, 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 up, 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 up. So it only changes the direction the one time. So we only have one extrema. So then let's do our domain and range for this because I want to practice it again. That was a little bit of a mess. So our domain, I'm going to write it below on here just so we are very clear. So domain has everything to do with our x values. What is the smallest my x values can be? Negative infinity. These arrows are pointing outwards. I know they're looking mostly up, but they're still going left and right. So it can go from negative infinity, as its very, very smallest, to what's the very biggest? Positive infinity. We're going to put them in parentheses. If you use parentheses every single time, honestly, at this point, I'm okay with that. We can deal with parentheses versus brackets later on, but we struggle getting those values a lot. So don't stress about the parentheses versus brackets unless we're confident in this part. I'm going to continue to use them, but I'm not going to fret about it. I had a lot of really, really chaotically random answers on the homework. A lot of the chaotically random answers were very, very similar, so I don't know what program we're using to try and read domain and range, but it's really bad at it. Stop using it. Just saying, there were way too many that matched and way too many people using some very calculus notation. If we're getting a little AI assist, air quotes, and you see a symbol that you've never written before, don't write it! I had a lot of people using stuff from calculus. I'm like, ooh, look what we accidentally learned. Stop it. Use some critical thinking, yo. All right, so that's our domain. It goes from negative infinity to positive infinity. What's our range here? The very smallest my y's can be. Our absolute lowest, oh look, it's relative to our absolute minimum, is negative 5. What's the very biggest my y's can be? Like infinity. It goes off my graph. It only stops because I ran out of graph. Then I ran out of paper. Then I ran out of screen. Then I ran out of ceiling. Then I ran out of lead. So it goes from negative 5 all the way up to as big as I can possibly imagine. Bracket on the negative 5, parenthesis on the infinity. Again, I'm not as stressed about our brackets versus parentheses. I'm going to continue to use them right, but not as stressed about it. What's up? Correct. Because the bracket means It's real. I can touch it. It exists. -5 is right there. I'm touching it. I can touch it on. I know you're just talking about that. I can touch -5 up here on my number line. It's right there. Infinity's somewhere that way. Maybe it's in D hallway. Maybe it's in B hallway. Maybe it's at 86 in Michigan. It's in that direction. But I don't know where it is, so I cannot touch it. Square brackets are only on things we can touch. Okay, questions on our f of x. That's how we read the f parentheses x thing. F of x. Which again is just a fancy name for y. He's in a mustache, dressed up in disguise. All right, let's look at the right one, our g of x. G of x is again y in disguise. It's just so I can say, hey, look, there are two different equations. I didn't want to call them both y. Literally the point of it. So I can say this is one equation, that's another equation. So let's start with our extrema, because that's our new bit. Then we'll do our domain and range on this one. Looking for those places where it changes direction. So if I go from the left and I start reading, we're going up, 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 down. Oh, right there is where it changed. So we have, watching our scale, we are at -2, +8 as our ordered pair. My x is -2, my y is 8. Is this a maximum or a minimum of flavor? It's a maximum. Is this an absolute maximum or is this a relative maximum?
Absolute. The arrow is facing up, so it goes on and on.
So it goes on up and up. So is this the highest it ever goes, or does it keep going up? It keeps going up. So this is a high point. I agree. It is a maximum, but it is not the maximumest ever. So this is a relative maximum. It is the highest of its neighborhood. It's the big dog of the high school, but it's not Beyonce. So this is a relative maximum. Are there any other places where it changes direction? Yeah. So from my relative maximum, I'm now going, all right, now it's going down, down, down. And then it goes up, 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 up. So I change direction again right here. So this guy is another extrema point. Extreme.
Relative minimum.
It is a relative minimum.
Because it keeps going on for infinity.
Mm-hmm.
That's right.
It's absolutely right. It's a relative minimum at the point 0, 4, because this is a valley. It is a low point. It's a fall. I don't know. Program. A valley. But it is not the very deepest in the entire world. This goes down more and more and more and more and more. So this is a relative minimum. It's the low points of the week. It's a little bit of a downer point. But it's not the absolute deepest it can go. It's not the lowest it can be. Okay, so questions on our relative max, relative min? Let's do our domain and range again. So what is our domain for this one?
-4, negative infinity.
Does it stop going left at -4?
No.
No. Where does it stop going left?
It never. So
It never stops going left. That arrow's pointed pretty good down. So it's going down a whole lot faster than it's going left. But it is still going left. It's going down and left at the same time. So this is still going to go from -infinity to positive infinity because it's doing the same thing going right. It's going like this, very, very steeply up and out, but it is still going out, just really, really slowly. So it'll get there eventually, but it's just going to take forever and ever and ever. Yes, dear?
What was the other one? It was like the X. I thought the domain was going to cross this.
That's intercepts. So x-intercepts is where it crosses the x-axis. Domain is just where does it stop going left and right. And range is the same thing but with our y. So y-intercept is where it crosses the y-axis and it will be a point. Our domain is going to be an interval, or you can put it as our all real numbers on this one. Because it can be anything. Let's look at our range on this one. What's our range going to be? What's the very, very lowest it can be ever? Negative infinity. What is the very biggest my y's can be? Positive infinity. And those both go in parentheses. And I know I'm right in that dark purple area. There, that's easier to read. Okay? Questions on these two? The next one, we're just going to do our extrema. We're not going to do domain and range because it's weird, and I also don't want to take up every second of our time. So we're going to find our extrema on this one. So look for some places where it changes direction and give me an ordered pair. 4, 2. Boop. Around here. 4, 2. And it's a little bit below 2, but it gets the point across for what we're talking about here. So what do we think? What kind of extrema is this? It's a minimum.
That's the absolute.
From what's shown on this graph, absolutely. It is the lowest we see on the graph. So this is a minimum. Is it the lowest it's going to go ever?
No.
Why not?
Because
there's an arrow that's pointing down. Even though it's above that point we found, it's not as low as this thing will go. This thing's got an arrow, which means it's continuing down over here. This line is continuing. So even though my arrow is above that point, it's still continuing down and it will go lower. So is this a relative minimum or an absolute minimum? Relative. It's like you had the point and you had the fact that it was a minimum. That is an excellent start. What is another place where we change directions? On 12, 11. Or 12, 11 and a half-ish. Somewhere up here. 12. I'm going to put 11.5 because it's a little far from the 11 for me to be comfortable with that, but we're going to rock it. What kind of extrema is 12, 11 and a half? Yeah. It's a maximum, definitely a peak. It is the peak of a mountain. So definitely a maximum. Is it the very, very highest it goes ever, ever, ever?
Yes.
Yes. So this is an absolute max. Where's another place? 14, 9. Yeah. Changes direction here. So if we look at 14, 9, What kind of extrema is that? A relative minimum. Because it's a low point, it's a valley. It's definitely not our lowest ever, but it is the lowest in that area. In fact, I'm going to zoom us in for a second here so we can see that. If I zoom it in right here, it looks like it's a low point. It is very clearly a dip, and then it comes back up. Definitely meant that to be the laser pointer and not the pink line. So it dips and then goes back up. So it's a valley here. But it is definitely not the lowest it ever goes. So it is a relative minimum.
16, 10.
Mm-hmm. Correct. 1610 is a relative maximum. Excellent. Okay. Kind of getting the vibe of it. It looks complicated. It feels like it was complicated, but it's finding our peaks and our valleys. Okay.
No, we ain't got nothing today.
Okay. So, turn in your bell work.
I didn't do it.
Turn in homework 2. And pick up homework 3. I'm going to put them up over here just because announcements are the reminder bell is going to happen here pretty soon. So turn in your bell work, turn in homework 2, pick up homework 3 from this little table. We are going to continue talking about it Tuesday and Wednesday, so it's not due until Thursday of next week. So homework 3 is not due until Thursday.
I'm not taking it right now.
It's right up here.
I'm not taking it. Can I not take it today?
You don't have to take it today. That's fine. But if you want to work on it over the long weekend and get, a third of the homework done, you absolutely can. Because the review you can do, and the extrema you guys can do. Absolutely fine.